All right, guys, we're going to start our day on 10.5. This is just more practice, just to kind of get exposure to the few theorems that we learned the other day, okay?
Okay.
So first of all, notice what's involved in this picture. We have a circle, and notice what's labeled are
The parts of the segments.
Okay.
And we talked a lot about segments and circles yesterday.
and what kind of segments are in this circle?
These are two chords that are intersecting inside the circle.
Okay, so when we have two chords that intersect inside the circle,
The product of the parts of one chord will equal the product of the parts of the other chord.
okay, so product means multiply. So let's maybe start with, this chord right here. So
Okay.
what parts are you going to multiply together?
I'm going to take the 2
Okay, so you're taking this 2,
times the 3x minus 1.
and since we're multiplying it times that whole quantity, I'm going to put that in parentheses. Okay, and we're going to set that equal to,
the product of the parts of the other chord. So I'm going to say an x minus 8, that quantity,
and notice, put parentheses.
and times the x minus 5, that other quantity.
Okay, so we got to set up. Now, here's the deal. This is all really the geometry behind this problem. Every thing from here on out is back to last year in Algebra 1.
Right.
Okay, so you guys can handle this. So what are we going to do first?
We need to distribute. So
Okay.
we've got our 2 times our 3x will be a 6x, and minus our 2. And over on this side, I'm going to have to FOIL it or distribute.
Which is still distributing, okay? So we're going to take this times that, so we get
An x squared minus 5x minus an 8x, and then plus 40.
all right, let's kind of condense some of this stuff. Over here, I can't really do much just yet. I'm just going to leave it alone. Over here, I can have x squared.
Minus a 13x plus 40.
All right, so what are you noticing here?
I notice that it's quadratic. And I notice I've got x squared along with x's and constants. So we need to set this equal to 0.
So basically, I need to move everything to one side. Which side would be the best on this one?
I'm going to move everything to the right. So let's subtract our 6x and add our 2.
And reason why, guys, again, that x squared is already over here. It's a little easier to do solving a quadratic when the leading coefficient is a positive, okay? So I'm going to move all of this over here so I get x squared minus a 19x and then plus 42.
Okay.
Okay, double check my math, make sure we're good. Okay, now at this point, we talked about this the last go around. We could solve a quadratic by using quadratic formula, right? We could even maybe solve by factoring. Now, this is one I would maybe consider factoring first if it's possible, since the leading coefficient is 1, and the constant is fairly small, that 42. So I might start thinking of factor pairs of 42. So one I'm thinking of right away is 2 and 21. Now, they have to multiply to get a positive, but they have to add to get a negative 19. So if I make them both positive, does that add up to negative 19?
No.
And if I make them both negative, does that add up to negative 19?
Doesn't.
What if I make the 21 negative?
Well, that would add to give me my negative 19, but it doesn't multiply to give me my positive 42.
Okay, so this really won't work out. Okay, obviously like 6 and 7 are factor pairs.
Those aren't going to give me to a negative 19 either.
So essentially, there's not any factor pairs that add up to that negative 19. So that means, what do we have to do?
That means it's unfactorable, so we're probably going to be using quadratic formula.
Okay, so quadratic formula, and we're not going to write down the formula again. You guys have seen this, all right? You should have it written down in your notes already. So I'm going to have x equals, and it's the opposite of b, so it would be
positive 19 plus or minus the square root of a negative 19 squared. And I love that you put that in parentheses because it's the whole number that's being squared, not just the 19 part of it. Minus 4 times 1 times our 42. All of that is over 2 times, and our a value again is 1.
Okay, so, and again, make sure that when you square this, if you type this in, negative 19 squared, it's going to give you a negative number. If you type it in, parentheses, or just ignore the negative, because we know
any number squared is going to be positive.
All right, so we're going to go ahead and simplify that down.
All right, and when I take negative 19 squared minus 4 times 1 times 42, I end up with 193.
All right, and this is, and then 2 times
All
1
over
is
2.
2. And this is, again, this is why we had to use the quadratic formula, because that 193 is not a perfect square.
Not a perfect square. So we're going to get some decimal answers.
Okay, so essentially this is going to give you 2 outcomes, all right? And I'm going to write down what basically this is saying, all right? And you guys don't have to necessarily show this, all right? Most of you can kind of think about it. But plus the amount, right, that's going to give you some rounded answer. Or, okay, you're going to have x equals a 19 minus that amount over 3, or over 2, sorry. And that's going to give you an amount. All right, so what's this?
The positive is going to give us about 16.45. And if I take the subtraction one, I end up with a 2.55. So they're both positive answers. Does that automatically mean that they're both right?
Well, here's the deal. Is x representing an actual length of the segment?
Well, no, it's part of the length.
Okay, so let's just go back and check. So this is what I would do. I'd go back in here, and I'm just going to look back at this segment because this is the easier one to kind of deal with. If I put 16.45 about minus 8, that's going to be positive. Same here, positive. If I put it here, it's going to be positive. If I put 2.55 here, minus 8, what are we going to get?
That's going to give us a negative segment length.
And we can't have a negative segment length. And here so as well. These values make this equation true, but for our geometry's sake, these are what we call extraneous solutions. They don't actually work out to the fact that we have a segment. So this one I'm going to omit, and this is the only one I'm going to circle.
Okay.
Okay, so this is one where you do want to check both answers and see, do they actually legitimately work for that problem?
Sounds good. For this next one, notice all we're doing is finding x. This was something that we did a lot of yesterday in our work as well. So I don't have to worry about finding any more than that, like find a whole secant segment or anything like that. But what do you notice that you have here?
Well, I see 2 secant segments that are intersecting outside the circle.
Okay.
And so I'm remembering that if I take the whole secant times the external, that product will equal the whole secant times the external on the other one.
Right.
So I'm thinking for the whole secant, the first one I'm seeing is the x and the 18 together. So that's going to be an x plus 18, not 18x. We're adding. So it'd be x plus the 18. And we're going to times that whole quantity times the external, which is an x.
Okay.
Equals the whole secant, which is 18, times the external, which is 8.
All right.
So I'm going to distribute on the left side. And that's going to get you x squared plus 18x. And then I'm going to multiply the 18 times the 8 and get 144. All right, I see a squared term and an x term, so that means I want to get it in standard form. So get everything to one side. So let's just subtract the 144.
Okay. And that minus 144 is going to equal 0 now, which is good. That's that standard form. Now, do we want to look at factoring this one?
Well, yeah, I think let's try it.
Okay, because 144 is not too bad.
Yeah, I could maybe think of some of those factor pairs and see if I can find those. So I know it's a negative 144. Okay, one of the first ones I think of is 12 and 12.
Yeah, I always think of that one first too.
And I know that if I make one of them negative, because it has to be one negative, those are not going to add to 18, so that won't work. So another one I think of is, what about like a 6 and a 24? And if I make the 6 negative, those add up to 18. So that's the one I'm going to use. Now, guys, again, what if you don't want to factor?
You don't have to. You could use quadratic formula for every single problem.
Anytime you have a quadratic, you can use quadratic formula. That's why it's called the quadratic formula, because it works for a quadratic. All right? So I'm going to go ahead and factor it. It's going to be the quantity x minus 6 times the quantity x plus 24 equals 0. And then essentially set each factor part equal to 0. And then I get 6 on one of them and a negative 24 on the other. Now I'm going to look back to see what is x. X is the external segment, so that means it can't be a negative. So the only value that would work in the case would be the 6.
Awesome.
All right, last one. Just a quick lesson here. Again, find x. What are we seeing in this picture?
Here I'm seeing a tangent segment and a secant segment.
All right, so what's the general rule?
Well, when they intersect at some point outside the circle, the secant segment, if I take the whole secant segment times the external part, it should equal the tangent segment squared.
All right, so the whole secant would be what?
That's going to be the whole 16.
Oh, I don't know why I did that. This whole thing is 16. So we're taking the secant times its external, which is
12.
And we're going to set it equal to the tangent. What's the tangent?
The tangent is our 2x, so we want to take that whole quantity of 2x and square it.
Now, if I just wrote it as 2x squared.
Yeah, that looks like it's just the x that's squared.
You're just squaring the x, right?
So, and I'm really taking 2x times another 2x.
So, and let me write that out. I like that you said that. You're taking a 2x times a 2x, which would get you 4x squared. Okay,
right.
Be careful. So you're squaring the whole thing. One reason why we're doing it is because this is a common mistake. Square the whole thing. All right.
So when we take our 16 times 12, that's going to give us 192. Is going to equal our 4x squared. Now, I notice on this one it is quadratic,
okay,
but I don't have an x term in there. I have the x squared, and I have the constant, but no x term. And when that's the case, it makes these problems a little bit easier to work with because I can just solve by taking a square root.
So basically, but here's the deal. Basically, you want to try to get the squared part by itself first. Don't take the square root.
Oh, yeah, not yet.
So we're going to basically divide by 4. And I know, and I bring this up because I saw this happen recently. Yeah.
Which is going to give us 48. And now I can solve by just taking a square root. X is going to equal, now technically it's plus or minus, and radical 48, which does simplify because 16 and 3 are factors of 48, so 4 radical 3.
So leave it in radical form. The only ones that you're going to just go ahead and round are the quadratic formula ones when you have to do it. Now, you said technically plus or minus.
Right.
Now, x represents part of the tangent segment. If I take 2 times a negative for radical 3, I'm going to get a negative. So really,
it's just
only the positive.
Yeah.
So let me kind of backtrack here.
Right.
And I'm just going to.
And the reason I said technically is because it does equal plus or minus. It's just that's not going to be necessarily the solutions that we'll use.
Exactly.
So 4 radical 3.